We're studying IGCSE chemistry and we're starting stoichiometry 3. Today we'll be learning all about hydrated salts, percentage yield, percentage purity, empirical formula, and not empirical mass, but molecular formula. Or as to be specific, finding molecular formula. Okay, now just to recap, you guys should already know these formulas. I'll just write it for you one last time. N is equals to mass by mR. We also know that C is equals to N over V. And we know that N is also, N is also
N is moles, right?
Yes, N is moles. This is for gases. For gases. Okay, so we know these things, mass by mR, and we also know that 1 dm cube is equals to 1000 cm cube. Now, I won't be explaining all of this today because we have done this. If you still have doubts, you can ask me, then I'll explain. No worries. Let's start with hydrated salts. And to do that, I'll be opening a question. Just give me a second. Now, can you see the question on the board?
Yes, sir.
Ayan, start reading.
Magnesium sulfate and lead sulfate are examples of salts. A student prepared magnesium sulfate crystals starting from magnesium carbonate. The student carried out the experiment in 4 steps. Step 1, the student added excess magnesium carbonate to a small volume of dilute sulfuric acid until no more magnesium carbonate would react. The student filtered the mixture.
Stop. All right. Okay, now,
yes, sir.
Neha, read step 2.
The student filtered the mixture.
After that, continue. Step 3.
Step 3. The student heated the filtrate obtained from step 2 until it was saturated.
Anas, step 4.
The student allowed the hot filtrate to cool to room temperature and then removed the crystals which formed.
All right.
Okay,
now
one thing. So basically, this isn't there in a textbook, right?
It's there.
Like
it is there in the practical chapter of analysis. And another thing, even if it's not there in a lot of detail, I will be giving all of this to you when we start doing alternative to practical. We'll do that. Right now, what I want you to do is, well, don't worry about this, okay? This isn't the best you can do. These questions are usually 6 marks. And these are only 4 steps. You have 2 more steps here. Forget that. This is actually salt formation. Okay, let's forget this for a second. Now
that's easy. Here. That's from acids and bases, yeah.
Acids and bases. Now, how did student know when the reaction had finished in step 1? How do you know if a reaction stops? Any guesses, anyone?
The
Until it stops fizzing.
Colorless.
It doesn't go colorless, never. It stops fizzing. So no more bubbles.
Effervescence.
Like no more effervescence, yeah.
No more effervescence, no more bubbles, no more fizzing. So no more effervescence. Effervescence, that's the fancy word we would like to use in the exam. But you can also use no bubbles or no fizzing. Same thing. All of those. This is the only answer ever for a reaction has stopped. Usually, about 95% of the time. We'll do more questions.
But if there is an indicator present, like in titration or something, we can also say when the indicator goes colorless or changes color, right?
But the reaction doesn't stop. The reaction is happening. It's just a change is happening. So the indicator doesn't tell us if the reaction has stopped. It will just tell us that some kind of thing has happened, right? Okay. But if bubbles stop appearing, that means there's no more reaction happening at all, right? Reaction has stopped. Now, they can ask you when should the titration be stopped. You'll say, okay, we should stop the titration when the indicator changes. That's something else. Now name the residue in step 2. We'll do this afterwards. This is not what we're supposed to do right now. We'll focus especially on a different question. Just a second. And let's go down. Let's go down. Okay. Manvi, read the question.
Magnesium sulfate crystals are hydrated. Another student heated some hydrated magnesium sulfate crystals in a crucible and obtained the following results.
All right.
Mass of
Okay.
hydrated magnesium sulfate. Okay.
Shreya, continue.
Mass of hydrated magnesium sulfate crystals is 4.92 grams. Mass of water removed is 2.52 grams. So we have to calculate the number of moles of water removed.
Number of moles of water removed. Now, just a second. I'll show you what a crucible looks like. This is what a crucible is. Okay.
Oh, it's like an evaporating dish. Yep.
Yep. This is what a crucible is. It's like a bowl. And you just fill the stuff inside here, and then you heat it. But you have to keep the lid on so if it doesn't escape. We'll do that afterwards. But that's what that is what is the meaning of crucible. Okay. Now
Okay,
let's
is it
move
made
on
of
here.
ceramic?
Yes, it is. Right, it's made of silica and a mixture of ceramic. Right. Now let's focus on this. Calculate the number of
I
moles
saw
of
it
water removed.
in class.
You saw it. That's good. Now, okay. How do I find the moles of water removed? Well, which formula will I use here? N is
First,
equals
you
to-
find out 1 mole of water and then you divide that with the answer.
Okay, so we have the formulas here, yeah, right here. Now you need to know that this guy is for gases, right? And therefore, I can only use either this one or this one. Now I have no clue about the concentration. I'll have to see if I have concentration and volume given, or if I have the mass given. Now, I can't use this guy because it's for gases. Let's see, is water a gas here? I'm going to remove this from here, just a second. Water is not a gas. It's just telling you how much is it removed. I've the mass given here. So the mass of water is given. Neha, can you see that? Anas, tell me the MR of water.
The molecular
Mass of water.
mass.
This is how we start.
I don't know.
You don't know? You don't know how to find it?
No.
No. All right. Anyone else? Neha, tell me the productive. By the way, Shreya, Ayan, Manvi, I need the answer for this one in the chat. Neha, tell me the
Okay.
MR of water. Now, Anas, look over here. You have the periodic table. Can you find hydrogen over here?
Yeah.
This is hydrogen. What is water?
Yes.
By the way? Water is H2O. You should know this. Okay. Now you
Yes.
have hydrogen, you have
Yeah.
oxygen. How many hydrogen do you have? You have two hydrogen. Two of these guys, one of this guy.
Hydrogen.
So hydrogen has a
Is it
mass of
18?
it is 18. Yes. Okay. So 1 into 2 plus 16. That's 18. So 2.52 divided by 18. The answer is, tell me. Where's Neha?
Yeah, I answer it.
All right. Someone answer. I haven't gotten any answers yet. Now, if you're this slow in the
Okay, it's 1.14. Sorry, 0.14.
0.14. Yeah, that's what. It's 0.14.
1.14. All right. Is that the exact answer?
It is.
Okay, then good.
Yes.
If it's not, I need 3 SF here. If it's not. Okay.
No, it's exactly 0.1.
That's good. All right. Calculate the number of moles of anhydrous magnesium sulfate that remaining in the crucible. The MR of anhydrous magnesium sulfate is given. Okay. Now, okay, how do I solve this question? How do we solve it? Come on.
You
Part
just have to
two,
do
be part
4.9.
Part 2.
Okay.
First, share read the question.
Calculate the number of moles of anhydrous magnesium sulfate remaining in the crucible. The MR of anhydrous magnesium sulfate is 120.
All right. They have given you the MR. Now the first thing again for finding moles is N is equals to mass over MR. Okay, that's what we have to do. Now we don't know the mass. We don't know the we do know the MR. First, let's write the mass here. So mass of anhydrous magnesium carbonate.
So that's 4.92 minus 2.52.
Yes. So how do we know this? So basically, hydrated MgCO3 minus water. Right? Mass of anhydrous MgCO3. Any doubt, anyone? Any doubts? This is how I find it. Now I know the hydrated salt, which is 4.92, and I know the water. So if I remove water from hydrated, it will become anhydrous. Anhydrous means without water, without H2O. It's dry. So the answer will be 4.92. Manvi, answer, tell me.
Okay, it's 0.02 moles.
0.02.
Okay, wait, no. I thought that was the final answer.
Others answer.
2.4.
2.4. All right. 2.4 grams, not moles, grams. Okay, that's we know that, fine. And have they given us the MR?
Yeah.
Okay, what is it? It is
I think so.
120. They have given it to us over here. Look, MR of magnesium sulfate is 120. So if I know it's 120, then I know the mass as well, 2.4. Anash, tell me the moles. The rest of you answer in the chat. The first one gets a point, yeah?
The moles. Wait.
Yeah, Anash,
so
tell me the moles. Say it to me, while the others write it in the chat.
No, I'm calculating it right now.
All right.
It's 0.02 moles.
0.02. All right. Now, Ayan, read the question.
Calculate the ratio of moles of anhydrous magnesium sulfate to moles of water. Give your answers whole numbers.
All right. So calculate the ratio of moles of anhydrous magnesium sulfate, right, with respect to moles of water. How do I find the ratio? It's always like this. So anhydrous, what is it? Yeah. So anhydrous. Ayan, work with me. The rest of you, I need the answer in the chat. It's a 1 mark question. It should take you 30 seconds. Ayan, work with me on the board. Anas, Manvi, Shrey, answer in the chat. The anhydrous, this is magnesium carbonate, MgCO3.
What was the mole of water again?
Moles of water. The moles of water was 0.14.
Okay, so it'll be 0.02 to 0.14, and then we have to multiply by a whole number to get a whole number.
No way. That's not what we're doing. Not at all. What we do is divide by the smallest one. Which of these is smaller?
0.02.
So divide both of them by the same number. Divide 0.02 and 0.14 by the smaller one. What do you get? 1 over here. 1:7. Is that clear?
Yes, sir.
Yeah.
I
How do
thought
I
it was a
find?
private message. I'm so sorry.
All right, moles and ratio. How do I find the ratio? If we first write down the moles and then we divide by smallest. Okay, divide all by smallest number. Now we'll do more of this outside of the past paper questions. But first, let's start solving this. So 1, we're almost done with this actually. 1, 7. Am I recording? Yes. Now suggest the formula of hydrated magnesium sulfate crystals. Okay, how do I solve this one? Now for this, I need Manvi, read the question. Ayan, I need the answer in
Yeah.
the chat.
Suggest the formula of hydrated magnesium sulfate crystals. Okay. So, can I see the formula of magnesium sulfate? Like, can I see the top of the question?
It's magnesium sulfate, not carbonate. I'm so sorry. Sulfate. MgSO4. Yep.
Okay. MgSO4.7H2O.
So MgSO4.7H2O. Is that? Are you sure?
Yep.
Okay. How do I do this? Okay. See, it's hydrated. All I have to do is salt. Okay. Salt dot X H2O. That's how we write it.
Yeah.
And this X comes from ratio. Okay.
Yeah.
Of water. Done. Now this is how it is. Now, any questions here? Any specific questions? All right.
Okay, but do we have to know uh, how like for certain salts do we need to know how much water is required and stuff?
Say that again. Say that again.
How much?
No, we don't need to.
How much? Okay, because in our class our teacher was telling us.
No, you don't need to know how much water is needed. Not at all. Not in this level. Not even in AS level. Perhaps in A levels. Not right now. Okay. Well, no, perhaps in A levels.
Alright.
You do have it in A levels, right? Hydrated salts, hydration, all of that. We have it, but not in IGCSE. Let's continue with the next question. Now we know how to do a question like this. What is the next thing? Percentage yield. Okay. Now before I continue to percentage yield, I'm going to give you a few. We'll do one more question on this. Okay. Now you have to do it on your own. So it's a skill check, and I want to know if you're learning or not.
We didn't learn about percentage yield yet though.
Yeah. I'm going. We'll do that. I'm giving you another question on hydrated salts. Another question on hydrated salts. Try this one. Now all of you start solving. It's a 4-mark question. Easy. Right? I need the answers privately, or not privately, sorry. I need photographs of all your notebooks. Do it on your notebook. And please don't think you can memorize any of this. Write everything down so you don't forget, or you can revise afterwards. Because whatever is in your head will be forgotten. Have you started solving it, Anas? Anas, can you hear me? I need the progress from all of you. Who's solving it? Who's not solving
Yeah.
it? Now,
I'm solving.
okay. Anas, where's your notebook? Now, I want you to get a sheet of paper, get anything, and start solving the question. Ask me doubts. Because you do realize
Okay.
this will come in the next test. We'll have a test on this, perhaps on Friday or Monday. So you need to ask me questions now.
Okay, I'm gonna go get a paper.
So for the moles of oxygen atoms, we're taking the MR of oxygen as 32 or as 16.
Say that again. I'm so sorry. Moles of
For
oxygen,
the
16 always.
yeah, so but then it's always found as diatomic molecules, right? So it's going to be 16 into 2.
But they're asking us the moles of atoms.
Okay.
Now, if they ask you the molecule oxygen, the molecule of oxygen, then you'll say 16 plus 16. So they will ask you. And usually, if they just say oxygen, that means an atom, right? The word molecule should be there. Otherwise, you're always taking 16, not 32, right?
Yeah.
Who is done?
Almost.
Almost.
All right, I got a paper.
Got a paper, start solving. Have to find the moles of iron, moles of oxygen, moles of water. And Manvi, if you focus here, they're saying water molecules. Yeah.
Yeah.
How do I find out the MR for iron?
Go to the periodic table on your book. In your book.
Oh, I don't have it.
You should have your book. Don't you haven't you
I'm
bought
not-
it?
Yeah, I have it, but I'm not at home right now.
You're not at home. So you're in luck today because I give all my students, I bring my own periodic tables so that you have it here. Just a second. Periodic table. This one right here. Now, check. Use the periodic table on the screen.
All right, thanks.
You're welcome.
Sure, can you go back to the
yeah.
question?
I'll go back to the question as well. Just a second. Now, Shreya, what is your progress? How much have you completed?
I'm really sorry. My internet is really bad over here. I'm at my grandparents' place, like I told you yesterday. So basically I left because of that, and now I'm back. I was done with the first one, I think.
Continue. Yeah, just continue solving it. Finish it quick.
Sir, could you help me with the last question?
The last question, the formula. All right. Just a second. Anas, what are you doing right now?
The first one.
You're able to do it? Yeah.
Yeah.
Okay, fine. Now, we'll discuss the whole question. Ayan, keep trying.
Okay, but I have a doubt.
You have a doubt? Okay, stop,
Is
Manvi.
what is the
Just a
okay?
second. Shreya, which question are you on? Part 1?
Yes.
All right. Okay, now we're going to discuss the question. Let's start with the first one. Now, okay, how do I solve the first one? Ayan.
Where you use the formula.
Yeah, use the formula N is equal to mass by mR.
Actual mass per relative atomic mass.
Yes, not atomic mass. Yeah, atomic mass in this case, because it's an atom. Same thing. AR, MR, same thing. Now, so, what are we doing? Now, 51.85 divided by 56. Yeah, that's iron. Which then the answer will be, Manvi, tell me.
It's 0.926.
0.926. This will be
Wait,
22.2.
I got 0.929 and I did 55.8.
85. It's given here. Yeah. Oh yeah. You did
No, I did
55.8. I see. Okay. So you should take 56. Take 56.
I took 55.8 as well.
You took 55.8 as well. All right then. Take 55.8. What is the answer? 55.8.
That's 0.92.
0.929.
925.
No, 9.
929. All right. Same thing actually. So it's okay. It's okay. They'll give you marks for this. Doesn't make a difference. Now use the exact one, whatever is in the periodic table in the exam. Check the periodic table which you have in the exam. Now 22.22 divided by 16 will give us how much? Answer, Manvi, Shrey.
1.39.
1.39. All right. I need the full answer. No rounding up yet. Right now. Okay. Now number of moles of water H2O.
I got 1.388.
388. Okay. Now 16.67 divided by 18.
The answer is actually quite long.
You don't have to write the full thing, at least 4 digits, right? You have to do the 3SF part at the final answer. Okay, no rounding up. So
Okay.
round up, give at least 4 or 5 digits. 4 digits minimum. For the answers in the behind the final answer. Now 16.67 divided by 18, that will give us how much?
0.926 again.
0.926 again. Okay. Simplest mole ratio FeOH2O. How do I solve this? So we'll write 0.93. First, they want the simplest ratio. They don't want just the ratio. So this is how we'll do it. First, we'll write the moles. So moles of FeO and H2O. Okay. So Fe was 0.929. This was 1.389 or 88. And this was 0.
Okay, I took it as 56. I took it as, I took the FE as 56.
Doesn't make a
I got
difference,
0.926.
right? Now, divide which of these is the smallest one? Is 0.929 or 0.926? 926. Divide all of these by 926. Now, these two are exactly the same. There is not a big difference. So these will be 1. And you'll get, what is the answer for the middle one? Divide all of them with 926.
I'm getting 1.49.
For this one, 1.49.
1.5.
1.5. Okay, for this one, 0.929 divided by 0.926. Answer, come on. I think it's 1.00. This is 1.5.
This is going to be 2
Yeah.
is to 3 is to 2.
Right? Okay. Now what happens is, even if, so you're getting a decimal now. Now it's your job to multiply with any number to make it whole numbers. Okay. Now what you do is, okay, how do I multiply it with? Let's say I can multiply this with 2. So I'll multiply all of these with 2 to get whole numbers. So I'll get 2, 3, 1, sorry, 2, 3. Yep. So the answer is 2, 3, 2. Is that clear? Done. Now formula for this sample of rust. Okay, this sample of rust. Now what is the
Wait.
formula of rust?
Did you multiply it by 2 because of the 2 in the H2O?
No, not because of that 2. I multiplied it with 2 because this guy was a decimal. I want to make this a whole number.
Okay.
So you have to multiply it with any number. Perhaps it could even be 3 if this gives you a whole number. The simplest ratio should be there. So
All right.
the formula of this sample of rust is, now what is rust? It's Fe2O3. Right? You should know this. Therefore, we'll put a dot here. X H2O. Now, what is the X over here? H2O, the ratio, the moles of H2O were 2. So 2. How do I know if it's how do I know if it's Fe2O3 dot 2H2O? Because look, we had 2 moles of Fe, so that's the 2 here. Then I had 3 moles of oxygen, so 3 moles of oxygen, and I had 2 moles of water, so 2 moles of water. Is that clear, Ayan? The answer is Fe.
Yes, sir.
2O3 dot 2H2. Now, Anas, question. No questions. Now, I think you should please note all of this down in your notebook and tell me when you're done.
Can I see the last one? Like, can you
Which one?
explain it again? The last one.
Yeah, I'll explain it again. Sure. Right. I can explain as many times as you want. Guys, please ask me. Now, formula of this sample of rust. Now we found the simplest mole ratio, right? Anas, any problems in the mole ratio?
Not the ratio, the next one.
Yeah, so no problems there. Yes. Okay. Now, how do I solve this question? I solve this question in such a way. I have iron, right? That is what I've been given in the question. A sample of rust had the following composition. It had iron, it had oxygen, it had water. So this is what it had: Fe, oxygen, and H2O. Now I know that it has 2 moles of Fe, so I'll put the 2 here. Now it has 3 moles of oxygen. So every 2 moles of water has 3 moles of oxygen. Okay. So this rust has, for every 2 moles of iron, they have 3 moles of oxygen. And I also realize that it has 2 moles of water. So I'll put that here. Now, whenever you're putting water, you have to put it in this format. The 3 comes in front of the water, right? So in the compound, put it like this: Fe, the number
Wait.
in the bottom.
Yeah. Isn't
Okay.
it like 2H2O?
Oh yeah, it's 2. It is 2. 2. Anas, clear? Got it?
Yes.
Fe2O3 dot 2H2O. That's your answer. Now that concludes hydrated salts. We'll do a lot more questions on this. You get assignments which you should finish to be able to have good marks in the exams. Now let's do something else. What is the next thing? Okay, guys, choose one from here. You have hydrated salts. Done. What else do we have? We're going to vote for these. I'm going to put a number here. 1, 2, 3, 4. I want you to message me privately. Which of these do you want to do? Shrey, Anas, Manvi. We're doing a voting. Just
Wait,
say,
sir, do you have to say it out or
no, direct message.
I can't open direct messages?
You can't open direct messages. Okay. Let's wait for the other one. Other people. Manvi, vote. Okay. Anas, vote. You still have to choose something, Anas. Now come on. Ayan, tell me your vote. Say it out.
3, empirical formula.
Empirical formula. So we have empirical formula has 1 with a voting ratio of 3:1. That's the ratio. We have
Wait, I pick the third one too.
yeah, you pick the third one too. Shred it the same thing. And Ayan. Okay. So Manvi the next thing we'll do is this one, percentage purity. Fine.
Sure.
So there's a ratio of 3:1, so we have to go with the majority. Let's continue. Next thing we have is empirical formula. Empirical formula. What is the meaning of this? Now, I have a question for this, but we won't really get into the question right now. We will start with some simple stuff. Let's say, first, I want you to write the definition in your notebook, if you haven't already.
It is the simplest ratio of all the atoms in a molecule,
Compound.
right?
Yes, in a compound.
Okay.
Write this in your notebook. What is the empirical formula? They'll ask you. This is about 1 mark in the question, 3 marks, right? You should make most of these marks. Now tell me when you're done writing.
Done.
Example number 1. Example 1 is perhaps, let's say you have C2H4. Now C2H4, what is C2H4? Which compound is this? Shreya, tell me.
Copper and okay.
Okay, I think it's calcium hydroxide.
Ethene. Ethene.
Calcium hydroxide and copper hydroxide. I
It's
see.
ethene.
It's carbon, guys. Come on. So it's okay.
Ethene.
Carbon.
Oh.
So it's ethene.
Yeah.
Yep. All right. Let's let the others join. Now, what do you know about empirical formula?
Okay, that you're supposed to write how many atoms are there without showing how they're bonded.
Right. Just write. Okay, we have to show the atoms. Now we don't care how it's bonded, and it's the formula. And it's also the simplest formula. So we have to simplify it. Algebra. Yeah. Just like algebra.
What
Yeah.
does that mean? Does
So that
C
becomes
equals
CH2.
I'll tell you what it means in a second. Now
So
let
it's
the other.
empirical formula is CH2, right?
Right, I'll tell you. So let's do this. Now, if C2H4, now Anas, all you have to do always is look which is the smaller number, 2 or 4. Tell me.
2.
Which is smaller? 2. Now divide both the numbers with 2. What do you get?
Okay, so I get 1 and 2.
CH2. Is that clear? Now that is your empirical formula. Easy?
Yep.
Okay.
Okay.
So
Now,
why did you write that thing?
which thing? EF?
The C equals C and then the H.
Oh, this guy. This is ethene. This is called ethene. That's the what do you call it? The displayed formula. Or let's just call
Do
it
you have to do that?
structural formula. You have to, yes, you have to write it on your notebook. Structural formula.
Like
I
I know in our notebook, but if it comes in the exam, so do we
no,
have to
yeah,
write it in the
yeah,
exam?
you have to write it. Yes, in the exam you have to write it. They will ask you what is this. They'll give you the formula, and you'll have to write the molecule for that. So this C2H4 looks like this because you have 2 carbons, okay, and you have 4 hydrogen. Okay, how will they be bonded? Now we know that carbon and hydrogen bond together, but now we only have 2 bonds for each carbon. So they make 1 bond with each other. Now we have 3 bonds for each carbon. And we know that carbon always makes 4 bonds. So what they'll do is they'll make 2 bonds with like this. So this is what it becomes, ethene. Why is it eth here? Why is this called ethene? Because
Okay.
eth means 2. And why is it called ene? Because of the double bond. Double bond. Now you don't need to know this. You need to know this. You do need to know this. But this is in the last chapter we did. I'll revise it. I think you guys need a revision in it. We'll do it later. I forget, you can note this down on your notebook. Tell me when you're done. Guys, guess who's back, right? Let's continue the class. Now, okay, whoever mic's on, otherwise you're going out of class.
All right. Also, sir, after the class, I have something to talk about. So, like, just like stay for 5 minutes.
All right, okay. Now, okay, we have C2H4 here. Let's try another one. I hope you've written down the definition of empirical formula. Now the definition. Now the next example is, let's say, C2H6O9. Okay. Okay. Before we do something that complicated, let's do 12. What is the answer? Empirical formula. Tell me.
It's CH3O6. CH3O6.
CH3O6. What do? We look at the smallest number, which is the smallest here, 2. We divide everything with 2. Okay.
Yeah. I do want to do C2H6O9 actually.
Does this actually exist? Like, what is the name of this compound?
No, it's something I made up. It doesn't exist. No.
Yeah, because the bondings are all wrong.
Yes, they are. So we're just trying to get it simplified. Yeah. Okay. Now let's see. What
We draw the
about?
structure of formula. I mean,
Now let's
we
try
draw
this
the
one.
thing.
C3H5, H15. Let's take O, or let's say F6 or F12. Tell me the answer. Empirical formula.
CH5F4.
Okay, that's pretty easy, I think. Yeah. Try this one. C2H6 O9.
Okay, CH3O4.5.
That's not correct. So you need the simplest ratio, as
You
in
can't
you
give
need
it
whole
as
numbers.
decimals, right?
You can't give answers
C2H609
in.
only then.
No, that's not possible though. Wait, no. Just a second. Just a second. Try making this.
3?
Yeah. Okay. So the answer is C2H6 O9. You cannot simplify this.
Yep.
Why? Why can't you simplify this?
Because O is odd. The number of O molecules is odd.
Yes. So this, if you get CH3 O 4.5, then you'll have to multiply with some number to make it whole, and you'll get the same.
Yeah,
thing.
and that number will be 2 only.
Yep.
So yeah.
Now what about this one? This one. C4. C4. Let's say. Answer.
C5H6O4.
Okay. Other people. I don't think that's the correct one. Perhaps it could be correct. It may not be correct. I need the other people to answer as well.
That is correct.
Okay, Amanvi, what do you think? Answer.
Yeah. So this will be C5H6O4.
Anas, is that clear? What are we doing? We're simplifying it. Yeah, that's all we're doing. You can simplify it. Yep. And I think that's
Dividing it by 10.
dividing it with 2. Because all of these are in the table of 2 or are multiples of 2.
Yes. Okay.
Yep, I think you can do this. Let's continue with something else. Now, we know that what is percentage composition? Percentage composition. We'll do this first. composition. Now, if I tell you find percentage composition of Na in, let's say, Na2CO3. Answer. Now, how do I solve this? What is the percentage composition? I'll give you the formula for this. Write it down.
1 second, I'm gonna go get paper.
Get a paper. Yes.
We did this exact same question in class today, so that helps.
That does help.
The
The
answer.
mass of let's say mass of element divided by mass of compound into 100. Is that clear? Note this on your notebook.
Yep.
Tell me when you're done.
So in the chat.
Write the answer in the chat. Note this down on your notebook. The
Okay.
formula. Now this right here is important.
Can you give us like the mass of Na or like the periodic table?
Yes. Just a second. You have it right here. Go on.
Carbonate would be 50.
Perhaps. But carbon is 12, O is 16.
No,
Na
it's 60,
is
60, sorry.
Na is always 23. You guys should memorize some of these because Na, especially sodium, potassium, magnesium, oxygen, carbon, and nitrogen. These 6 you should memorize. Now I'm going to solve this for you. I need the answer in the chat as well. Anas, work with me on the board. Can you hear me?
Yeah. I'm
Now
just
find-
writing it down right now.
Okay, write it down first.
All right, done.
Done. All right. All right, good. Now find the percentage composition of Na in, am I recording? Yes. Na in sodium carbonate. Okay, fine. How do I solve this one? Now I need to know the percentage of the mass of sodium in this. We have two Na2 here, so I'll take 23 into 2 divided by 23 into 2 plus magnesium carbonate
My
is
answer's
carbon
in
is
the chat.
12. Oxygen is 3 times, so 3. 16 into 3. Solve this, what do you get?
You get 23 into, wait, let me get open calculator.
I think it's 31.506%. Others, check the answer. Tell me if it's correct. And multiply that with 100 always, because percentage, this word percentage here. Ayan, Manvi, any doubts here? Can I move on?
Yes.
Yes, all right.
I got 4,000.
I don't think mine is correct. I realized something.
Okay, check again. Use the calculator. Manvi, I need the answer.
Okay,
Yeah,
I
it's just
got
incorrect. I got
43.4.
43.4. I'm going to assume that's the correct answer. Now, all you have to do is use your calculator, plug the numbers in, you get the answer, okay? Use the correct formula always. Now, this is for percentage composition. Now, we'll try a question over here. Just a second. This one. Copy image.
Okay, is the answer 43.39?
43.39, yeah. So 3SR,
Yeah.
43.4.
Okay.
Now let's go downwards. Let's finish this question. Now the first question is about purity, which is chapter number 2 perhaps, or chapter number 3. But we'll do it. It's pretty easy. Start by reading the question. Ayan, read.
Compound X is a colorless at room temperature. A sample of pure X was slowly heated from -5 degrees Celsius, which is below melting point, to 90 degrees Celsius, which is above its boiling point. Its temperature is measured every minute, and the results are represented on the graph.
All right. Actually, you can do this afterwards when you look at the question. This is chapter number, I think, chapter 3. CH3. Now this is chapter 5. That's what we are doing. Man, we read the question.
Compound X is a hydrocarbon. It contains 85.7% carbon. The mass of 1 mole of X is 84 grams.
All
What
right.
is the
Okay.
percentage of
For percentage of hydrogen in
the
compound. In the compound.
okay,
Yeah.
yeah.
Okay. Now let's start by solving. How do we solve a question like this? I'm going to give you a method here. So this is about finding molecular formula method. Please note this down. You have to repeat this formula every time you get a question like this. Just rinse and repeat every time. So I hope you're ready to write. First step is always the mass. Now, before you even write the first step, you have to write all the whatever you have. You first have hydrocarbon X. Okay, hydrocarbon X, and you have carbon and hydrogen in the hydrocarbon, because hydrocarbons only have hydrogen and carbon. Now we'll write the mass of these. You need to realize that the mass will always be the same as the percentage. So whatever the percentage is the same thing as the mass. So I have 85.7%, 85.7%, or just a second, write the percentage composition, percentage. So carbon is 85.7. Hydrogen, what will hydrogen be? If this is 85.7%, this will be 100 minus 85.7. Yes? What is the answer? %. The second step, mass.
Wait, what class do we have next?
I am not sure, but let's finish this one first.
Yeah.
Now, first you wrote the percentage composition. This is given in the question, and if something is not given, you can find it out, because the whole must be 100. So if carbon is 85.7, then the rest must be 100 minus 85.7, which is 14.3. The next step is finding the mass, and in this step, all you have to do is write the same thing again, 85.7, but remove the percentage and put gram here, and again hydrogen will be 14.3. Remove the percentage, put the gram. Third step, moles. Now give me the moles of both of these. You know the mass. What is the moles? What are the moles?
Okay, so moles is equal to mass by molar mass.
Molar mass. So N is equal to mass by MR.
Okay, so I'm directly finding the moles by just dividing the mass by the
Yeah, directly find
moles.
it. You don't have to write it.
Yeah.
So 85. So I'll write it here for you to understand. It's going to be 85.7 divided by 12, which is equals to. I need the answer in the chat, Ayan. Or say it to me, Ayan. Say it. And 14.3.
If I say it first, am I a better student?
7.14. Good job, Trey.
7.4. Okay. 7 point. Okay. Now, what is the Shreya? What is the MR of hydrogen?
I think 2.
Okay. Manvi,
It's 1.
MR 1. It's always 1. So 14.3.
Yeah, it's 14.3 only.
Yeah.
Now
So
4.
it's 6 is to 14.3.
Now we'll find the ratio. How do I find the ratio?
Okay, for moles of carbon, I got 6. I got 5.999.
5.999. Moles of carbon.
Okay, so we
Yeah.
can give the approximate ratio as 1:2.
No, no, it's not. It's not really. This is the correct answer. 7.14 moles. Okay. Now, how do I find the ratio? Divide it by the smallest number. This is the smallest one.
Yeah.
Anas divide it, so we'll get 1 here always. 14.3 divided by 7.12 will be 2.00 something. Okay. So the ratio
Okay,
is
but
1 is to 2.
the moles of uh, this thing is moles of carbon is 6, not 7.14. I did it on the calci.
85.7 divided by 12.
Okay.
Sir,
The
so
EF is uh,
I did
Right?
it
C8.
85.7 by 100 into 12, and then wait,
No,
yeah, and
okay.
then the whole thing divided.
Okay. Manvi, we'll talk about this in a second. Let's finish the question first. You're going to get 7.14. That's what you're going to get. I'll talk to you about it afterwards. Why you didn't? Okay. Now this is what you get after this. Let's look at the step after this. Ratio. Now how do you find the ratio? Divide by the smallest number. You get 1 is to 2.
yeah,
1
yeah.
is
So
to
it'll
2.
be CH2.
So okay, now I need the empirical formula. What is the empirical formula?
Is it CH?
CH, not CH. No, it's not CH. It's C1H. What? What is H?
2 H2
H2.
CH2.
The CH2. Right? You don't have to write the one. CH2, then what is
Okay.
sixth step, final step? Empirical mass.
Empirical formula is CH2 only.
Empirical mass.
Empirical mass. Oh, wait. Simplest formula must be, would be.
Anas, write the whole thing down on your notebook. Empirical
Oh,
mass.
just like molecular mass, this is empirical mass then.
Yes. So 12
So
plus
it'll be 14.
14. Finally, seventh step. Multiplying number. What is the
Uh,
So
multiplying
multiplying
number?
what?
Multiplying number.
2.
Not 2. We'll look at it in a
Usually
second.
it's
How do I find this
C2H4,
multiplying
right?
number? No, it's empirical mass. Sorry, molecular mass divided by empirical mass.
Yeah. So
What is the
that
molecular mass here?
is
They have given us here. The molecular mass of 1 mole of X is 84 grams. Can you see that?
Wait,
1.53.
how did you get 12? How did you get 12?
84. 12 A. 12 here because carbon is always 12. Okay, mass of carbon is 12. So MR is
Sorry.
84 divided by 14.
6.
Answer 6. Therefore, all you have to do is the molecular formula MF is EF times multiplying number. Number. Therefore, your
yeah.
MF will be CH2 times 6, or which will be C6H12. That's your answer. Is that clear?
Yeah.
Who has not
Yes,
written
sir.
this, take a screenshot. That's all for today. Take a screenshot, quick.
All right. I need to talk to you, so just like stay for a second.
All right, it's okay. Manvi, talk to me about your doubt. Any questions
Okay,
here?
so
Yeah.
the way I saw this was 1 second. I'm finding the page. Yeah. So
Guys, please write this on your
for
notebook.
first,
Yes, Manvi.
I wrote it all. So
Ayan,
first,
write it
what I
all as
did
well.
was
Yeah. Yes, Manvi.
to find the mass of carbon. I did 85.7 by 100 because that's the percentage into 84,
So you don't have to do
and
that.
then
No. Don't divide it by 100. Keep the same thing. Okay? Keep it exactly the same. The percentage so just remove the percentage sign, make it grams. Now what are we assuming? We're assuming that we're taking 100 grams of X. So in 100 grams of X, what is the mass going to be? In 100 grams of X, the mass will be 85.7, right? If let's say 85%, 85.7% is the percentage composition, then if you take exactly 100 grams, then carbon will be 85.7 grams. So all you have to do is replace the percentage sign and put a gram sign over there. Is that clear? And then continue from there. So you'll get 85.7
Yeah.
grams divided by 12. You should get 7.14. That's the answer.
Okay.
Now
Yeah.
please write the whole thing down and then leave. After you've
Done, sir.
finished. Done? Sure?
Yes, sir.
All right. Now if you can repeat this, being clear of this method, it will help you a lot in chemistry, in every kind of questions. Okay. Now,
Yeah.
Ayan, you're finished. You can go. Take care. Goodbye.
Thanks for take care. Goodbye.
All right.
Now, Manvi, can you hear me? Manvi, can you hear me?
Yep. All right. So basically,